Box plot, a simple tool to visualize data distribution. Let's talk about the box plot, also known as a box and whisker plot. This is a graphical summary of a dataset's distribution, and it's particularly useful when we want to understand the spread, center, and variability in our data. A box plot displays key statistical measures: the minimum, first quartile, Q1, median, Q2, third quartile, Q3, and the maximum. These form the box and the whiskers of the plot. The box itself shows the interquartile range, IQR, which contains the middle 50% of the data. The line inside the box marks the median, giving us a sense of the data's central tendency. The whiskers extend to the smallest and largest values within 1.5 times the interquartile range from the quartiles. Any data points outside of that range are typically shown as outliers. What makes box plots especially powerful is that they allow quick comparison across multiple groups or data sets. We can visually assess how distributions differ, whether one group has more variability, a higher median, or more outliers than another. In summary, the box plot is a compact visual way to convey important aspects of data distribution, all at a glance. Let's take a closer look at the components of a box plot and what each part tells us about the data. The box itself represents the interquartile range, or IQR. That's the middle 50% of the data. The lower edge of the box marks Q1, the 25th percentile, meaning 25% of the data fall below this point. The upper edge marks Q3, the 75th percentile, so 75% of the data fall below that value. Inside the box, we have a horizontal line. This is the median, or the 50th percentile. It shows the middle of the data set. Extending from each end of the box are the whiskers. These lines reach out to the smallest and largest values in the data set that are not outliers. Essentially, they capture the range of the typical data. Now, what about values that are far outside the rest? Those are shown as dots beyond the whiskers, and they're called outliers. Outliers are unusually high or low values that don't fit the general pattern, and they can be important indicators in data analysis. So altogether, the box plot gives us a compact summary of the data's center, spread, and any potential outliers, all in one visual. To fully understand a box plot, we need to first look at the number summary. These are the core statistics that serve as its building blocks. They include minimum, the smallest non-outlier value in the dataset; first quartile, Q1; the 25th percentile, where 25% of the data lie below this value; median, Q2; the 50th percentile, the center point of the data; third quartile, Q3; the 75th percentile. 75% of the data fall below this point. Maximum, the largest non-outlier value. These 5 numbers form the basis of what's known as the 5-number summary, and they're exactly what a box plot visually represents. Now, once we have a box plot created from this summary, what can we learn from it? First, we see the center of the data, shown by the median line inside the box. This helps us understand the typical value. We also see the spread, how spread out the data is, which is indicated by the length of the box and the whiskers. Next, we can assess symmetry versus skewness. If the box is centered and whiskers are roughly equal, the data is symmetric. If the box is shifted or one whisker is much longer, the data may be skewed. Outliers are also easy to spot. They appear as individual dots beyond the whiskers. And finally, box plots are excellent for comparing multiple datasets side by side. You can quickly spot differences in medians, spread, and outliers across different groups. In short, a box plot condenses a lot of valuable information into a single, easy-to-read graphic. Now let's look at how to interpret skewness in a box plot. This tells us about the shape of the data distribution. First, if the data is symmetric, you'll see the median line roughly centered within the box, and the whiskers are about the same length on both sides. This suggests that the data is evenly distributed around the median. No significant skew. If the data is skewed to the right, also called positively skewed, the median will appear closer to the bottom of the box, and the upper whisker will be longer. This means there are more smaller values and a few larger ones pulling the tail to the right. On the other hand, if the data is skewed to the left, or negatively skewed, the median shifts upward, closer to the top of the box, and the lower whisker is longer. This suggests more large values with a few small ones pulling the tail to the left. Recognizing skewness in a box plot helps us understand whether the data is balanced or biased toward one end, which is key in selecting the right statistical methods and interpreting results accurately. Let's now look at a couple of real-world examples of how box plots are used. One from manufacturing and one from the service industry. Manufacturing. Example, suppose we plot the defect rate across 4 production lines, A, B, C, and D. We notice that line C has higher variability, which means its box and whiskers are longer. The defect rates are less consistent and more spread out. Line D has a lower median defect rate, indicated by a lower line inside the box, which is a good sign of performance. Interestingly, line A shows an outlier, a spike in defects on a particular day or batch. That dot beyond the whisker flags an exceptional case we might want to investigate further. Service industry. Example, now take a box plot comparing customer wait times across 5 service branches. Branch 2 stands out. It has the longest median wait time, meaning customers typically wait longer there. It also has the most variability. The box and whiskers are wide, indicating inconsistent wait times. Plus, there are outlier days, maybe due to understaffing or high traffic, that are represented by dots beyond the whiskers. These examples show how box plots are incredibly useful not just for visualizing data, but also for identifying issues, comparing performance, and guiding improvement efforts in both manufacturing and service environments. How to create a box plot in Minitab. Let's walk through the steps to create a box plot using Minitab, a widely used statistical software. First, open Minitab and ensure your data is entered in columns. Then go to the Graph menu and select Box Plot. You'll have options. Choose Simple for a single dataset or with groups if you're comparing categories, like departments or branches. Next, select the columns of data you want to visualize. Finally, click OK, and Minitab will generate the box plot. It's quick, and the visualization can immediately help highlight key patterns or issues in your data. Common misinterpretations of box plots. While box plots are powerful, they're often misunderstood. Here are some important points to clarify. First, remember that a box plot does not show the mean unless you specifically add it. The focus is on the median and quartiles. Second, box plots don't show the exact sample size. Whether the dataset has 20 or 200 points, the plot looks the same unless additional annotations are made. Third, individual data points are not shown unless you choose to include them, usually as a modified box plot or a dot plot overlay. And lastly, don't assume the data is normally distributed just because the box plot looks symmetric. The shape can give clues, but it's not enough to confirm normality on its own. Understanding these limitations helps avoid incorrect conclusions and makes your analysis more reliable. How to create a box plot in Minitab. Let's walk through the steps to create a box plot using Minitab, a widely used statistical software. First, open Minitab and ensure your data is entered in columns. Then go to the Graph menu and select Box Plot. You'll have options. Choose Simple for a single dataset or with groups if you're comparing categories, like departments or branches. Next, select the columns of data you want to visualize. Finally, click OK, and Minitab will generate the box plot. It's quick, and the visualization can immediately help highlight key patterns or issues in your data. Common misinterpretations of box plots. While box plots are powerful, they're often misunderstood. Here are some important points to clarify. First, remember that a box plot does not show the mean unless you specifically add it. The focus is on the median and quartiles. Second, box plots don't show the exact sample size. Whether the dataset has 20 or 200 points, the plot looks the same unless additional annotations are made. Third, individual data points are not shown unless you choose to include them, usually as a modified box plot or a dot plot overlay. And lastly, don't assume the data is normally distributed just because the box plot looks symmetric. The shape can give clues, but it's not enough to confirm normality on its own. Understanding these limitations helps avoid incorrect conclusions and makes your analysis more reliable. Summary. To wrap up, let's review the key takeaways about box plots. A box plot is a visual summary that shows important aspects of a dataset, including the median, interquartile range, IQR, variability, and outliers. One of its strengths is how easily it allows us to compare multiple groups side by side, making it perfect for analyzing differences across teams, processes, or time periods. It's also a valuable tool in the Lean Six Sigma toolbox, helping identify variation, monitor process stability, and uncover hidden issues. In short, a box plot simplifies complex data into clear visual insight, giving us an efficient way to spot trends, issues, and opportunities for improvement. Final thought. Remember, numbers tell a story, but sometimes that story is buried in rows of data. A box plot brings that story to life visually. Fast, clear, and powerful. It's not just about data. It's about seeing the signal in the noise.